This is AS Module 2, a paper from January 2010. Question 2 focuses on the topic of lenses. And in this question, you should answer in continuous prose where appropriate, and you will be assessed on the quality of your written communication. This question is wholly about an experiment to determine the focal length of a converging lens. Your description should include a fully labelled diagram of the apparatus you intend to use, an outline of the method employed, the results to be taken, and an analysis of how the results can be used to obtain a value of the focal length of the converging lens. So there's several different aspects, and there's a second page on which to write. So this is an extended descriptive question. So first off, a fully labelled diagram of the apparatus you intend to use. Well, again, using a ruler, you can draw a diagram. We have a screen, we have a lens, and we have an object. And the object must be illuminated. So if we label this as a torch, and we call this an illuminated object, refer to the fact that it's illuminated because that's necessary. This is the lens, and this is the screen. What's also helpful is if you identify on the diagram your object distance and image distance. This isn't absolutely essential, but it helps in your description later on. And I would call it object distance U and image distance V. So what we have is the apparatus we intend to use, a torch with an illuminated object, the lens, and a screen. And we've identified the object distance and the image distance. So that's part A done. For part B then is the practical method to be employed. And the first step is place the object at a fixed distance from the lens, and this is U, and record the value of U. Then we move the screen. So we have the object placed at a certain distance from the lens, and we're going to adjust the screen now to get the position for a sharply focused image. So move the screen to find a position. Which gives a sharply focused image. Measure and record the image distance V. Using a meter stick. Okay, and that's something we should have perhaps drawn into our diagram, is to then have a meter stick. And sometimes whenever you're doing your method, you will find you've left something out of the diagram and you can return to it. So firstly, we place an object at a fixed distance and record the value of U. Move the screen to find a position which gives a sharply focused image. Measure and record the image distance V using a meter stick. And then, moving on to the next page, repeat this process for at least 3 values of U. 3 different values of U. So, going back to the question then, we now have a fully labelled diagram. We have an outline of the method employed. We need to now, we've identified the results to be taken, but it would do no harm to emphasise that again. So, ensure to record the values of U and V in a table. So we now have the measurements. And finally, the last part of the question asks us to describe an analysis of how the results can be used to find a value of the focal length of the converging lens. So the first thing I would say is calculate values for 1 over u and 1 over v. Plot a graph of 1 over u against 1 over v. The intercept on actually either axis write that in as either axis is 1 over f. So find the reciprocal of the intercept to calculate f, which is the focal length. So overall in that question again then we had to describe an experiment. We have a fully labelled diagram of the apparatus we're going to use. We have the method whereby we place the object at a fixed distance, move the screen to find a position which gives a sharply focused image, and measure u and v and record them. And repeat this process for at least 3 values of u. Record u and v in a table, calculate values of 1 over u and 1 over v, plot a graph of 1 over u against 1 over v where the intercept on either axis will give us 1 over f. We then find the reciprocal to calculate f, which is the focal length.